Hello everybody, welcome back to another video of the system design playlist. In this video, we are going to discuss about message queues. What are message queues? We are going to discuss about a brief intro, and then we are going to jump onto the core components of the message queue and how do message queue actually work. Okay, and then what are the types of message queue? We are going to discuss about it. Advantages of message queue, when to use a message queue, what are the best practices for implementing them, and there are some popular message queues. We are going to discuss about them. What are message queues? So first of all, let's discuss about message queues. A message queue is a communication mechanism that enables different parts of a system to send and receive messages, and in the form of asynchronous. So asynchronously. Remember this word, asynchronously. Message queue is a communication mechanism which enables the different part of a system to send and receive the messages asynchronously. So like it acts as an intermediary that temporarily hold the messages and send from the producers, which we called as publisher, and delivers them to the consumer, or we call as subscriber. So it acts as an intermediary. Okay, intermediary. So it acts as an intermediary between the publisher, which is the producer, and the consumer. So the publisher is sending the message and the consumer is receiving the message, which we call as pub sub. Okay, so suppose this is a publisher, okay, it is going to send a message. Here the message queue, in the form of a queue, it is going to store the message. Okay, we have a message queue here. It is going to store the messages, right, in a queue format, and then when required by the subscriber or the receiver, here receiver is the consumer actually. So when needed by the consumer, here we have consumer or the subscriber. Okay, so what we are doing is publisher is sending a message and temporarily message queue is holding that message. It is storing that message in a queue form, and then it is going to give it to the consumer. So suppose this message is consumed. Now what we do is we can easily remove this message here, this one. Okay, so now this message is removed. Now we only have 3 messages here. Previously we had 4 messages. Now we have only 3 messages here. And then when the queue is empty, like when there is available space, so we can add a message, another message from the publisher here. Okay, this is how the message queue works actually. So what are the key characteristics of a message queue? It allows components to communicate without needing to be aware of each other's existence. The publisher doesn't know about subscriber and the subscriber doesn't know about publisher here. So this leads to a decoupled architecture. This enables a decoupled architecture. Okay. Now let's discuss about the core components of a message queue. What are the core components of a message queue? First, we have the producer, which we call as publisher. Okay, we have the pub and sub, which we call as consumer. Okay, first let's discuss about the producer. What is the producer? We also call them as publisher, the entity which sends a message to the queue. Here the producer is sending a message to the queue. It is sending a message to the message queue, and producer pushes the message into the queue without worrying about the consumer state. The producer doesn't know about consumer. It doesn't know what the consumer is. It is just giving its message to the broker, which we call as the mid person. Okay, it is giving its message to the message queue. It doesn't know about the consumer anyhow. Then we have consumer. What is a consumer? Consumer is the entity which reads the message from the message queue. It reads the message from the message queue. So consumer pulls the message from the queue and process them. Consumer doesn't know about the producer as well, vice versa. Okay, And then we have the queue, which is the actual component. We have the message queue, the data structure which stores the messages until they are consumed. So it is holding the message. Suppose this is a message 1, okay, and this is a message 2, this is a message 3. It is holding the message and giving in the form of first in first out. Okay, it is giving in the form of first in first out. So here the first message, suppose this was the first message, okay, this was the first message in the form, and this was the second message, and this was the third message. Let me erase this. This is the actual sequence. This was the first message, this was the second, and this was the third message. This is first in first out format. As you know about the queue follow first in first out. So it is a data structures which stores the messages until they are consumed by the consumer actually. Okay, here we have the term broker. Why do we call it as a broker? So broker is a queue manager actually. Okay, so this is the fourth component. It is the queue manager which is managing the queue. Okay, the software or service that manages the message queue handles the delivery of the messages and ensures that messages are routed correctly between the producer and a consumer. Suppose this producer is sending a message and it reaches to some other consumer. Suppose there is a consumer 3. Okay, it is reaching to another consumer, the place where we don't want to send our message. So the broker actually controls all the routes. Okay, remember, it controls the routes here. And the main component here is the message itself. The message is the major thing that we are delivering. It is the unit of data sent through the queue. Remember, it is the unit of data. This is a unit of data, okay, which is sent with the help of a queue. The message typically contains the payload. It actually contains the payload. Okay, what is a payload? Payload is the actual data being sent, and it is also containing the metadata. What we call as metadata? Metadata such as you have header, or you are sending a timestamp, or you are sending any kind of priority. So metadata holds all those things, and payload is the actual data that is being sent. Now let's discuss how a message queue actually works. Let's discuss with the help of a diagram, with the help of the architecture of the message queue. So first of all, there happens a message creation. Okay, the first step is message creation. So a producer generates a message. This is a message. Okay, this is a kind of message which is generated by the producer. It contains all the necessary data. For example, as we have discussed in the previous slide, it contains the payload, which is the actual data. It also contains the metadata, such as the information of your header, whether you are providing any timestamps or not, and the priorities of the message queue. Okay, so now the message is generated successfully. Now the second step is message enqueue. Okay, the second step is message enqueue. What is message enqueue? Enqueue means the producer sends the message to the queue, okay, where it is stored until a consumer retrieves it. So enqueue means this message is going inside the queue, and now it is stored inside the queue until it reaches to the consumer. And then we have the third is we have message storage. We have message storage. Okay, what is a message storage? Message storage means the queue stores the message in a persistent or transient manner based on its configuration. Based on configuration means what is the priority of the message, what is the priority of the queue. Okay, so based on that, it is going to store that particular message. The fourth is, so the fourth and very important, which is message dequeue. Message dequeue. What is the meaning of message dequeue? Like we have discussed about message enqueue, we have message dequeue. Here you can see the blurred message here. So this is message dequeue. Means now the message is out of the queue. So this is known as message dequeue. Okay. And then we have acknowledgement. Once the consumer receives the message that we have dequeued from the queue, it goes to the consumer. Consumer actually receives the message and it checks all the details, and after checking it, it sends an acknowledgement. Like it is saying to the queue, hey, I have already received the message that you have sent to me. So it sends an acknowledgement to the queue, and then queue sends, for example, this message was to be sent to the consumer 2, and now the remaining message is to be sent to the consumer 3. So the acknowledgement goes to the queue that consumer 2 had successfully received the message. Now the second message is going to be delivered to the consumer 3. This is how the acknowledgement works. And there is very important thing which we call as message deletion. What do we mean by message deletion? So if we have message queue and we enqueue and we also have a message dequeue, why do we need deletion? So after the acknowledgement is done, the broker, which is actually the queue manager, okay, the queue manager, what it do is it removes the message from the queue to prevent it being processed again. So if I am not going to remove this message from this place, then I am going to process this message again, because it works on a first in first out manner. Okay, so I am going to process it again. Okay, so it is my duty to the messages which are already processed should be removed from the queue. So I perform a delete operation. Here I perform a delete operation. I hope you got my point. Now let's discuss about the types of message queue. What are the types of message queue that we have seen? So the first is point to point queue. First is point to point queue. We call it as P2P queue. Okay. So what is a point to point queue? So in this model, the messages are sent from one producer to one consumer. It is used when a message is need to be processed by a single consumer. Such as you have a task processing system. You might have seen a task processing system where there is a need of point to point mapping, one to one mapping. Okay. So one producer and there is one consumer. The second is pub sub. The second is pub sub. What is the meaning of pub sub? Pub means here we have publisher, and sub means we have subscriber, which means publish and subscribe queue. It is a publish subscribe queue. Okay, so this one is actually the pub sub queue. This one is actually a pub sub. How this model actually works? So in this model, messages are published to a topic. Messages are actually published to a topic. Okay, what is the meaning of a topic? Means there is a particular topic, okay, on which the queue is made, and there are multiple consumers that can subscribe to that particular topic to receive the messages. So there are multiple consumers, like you have one, you have two, and there is third one as well. It is used for broadcasting a message to multiple consumers, such as you have like notification system. Recently the war is going on between USA and Iran. So what you are doing, you are seeing a producer and consumer. So even if there is single producer, which is a broadcast channel, so it is going to send the message to the topic and it is going to broadcast it to the multiple consumers. This is known as multiple consumer are getting the same message. Okay, so even if you have a single producer, you are getting all the consumers are getting the single with the help of a topic. The third is we have a priority queue. We can also use a priority queue. So this is also a kind of queue which assigns priority to the messages. The highest priority message will be delivered firstly to the consumer, and the low priority message will be delivered at last, as we have discussed in the previous slides. So it is used when certain tasks need to be handled more urgently than others. For example, if you want to update a software, it can be delayed. Okay, but if you urgently need to see a video, it cannot be delayed. So the priority is more to a video than to updating a software. Okay, so this is how it actually works. The fourth is we have a dead letter queue. Okay, fourth is dead letter queue. We also call it as DLQ in short term. So let's discuss how it actually works. We have a producer, we have a queue, we have consumer, and like we can see there is a failed message and a dead letter queue. Let's discuss how it actually works. It is a special type of queue where the messages cannot be processed due to errors or retries. Okay, so it is useful for troubleshooting and handling the failed message. For example, the producer is sending the message to the queue. It is going to be enqueued to the queue. Now it is stored in the queue. Okay, and somehow if the message is not sent to the consumer, somehow if there is any kind of error, suppose there is an internet failure. Okay, there is internet failure, so the message is not sent to the consumer, or if there is any kind of error, suppose there is an attack, okay, on the message, so there occurs an error in the pipeline, there is a failed message. Now the message is actually stored in the dead letter queue. It is actually stored in a dead letter queue. When the consumer again hits for a retry, or it requests for the message is actually carried from the dead letter queue and it is sent to the consumer. Okay, so it is used for troubleshooting and handling the failed messages. Like whenever you have suppose your driver is not working in your computer, so you go to the troubleshooter and you hit a troubleshoot, and what you see is you can get a solution after that. So it is actually a solution which is coming out of the dead letter queue. Now let's discuss about the advantages of message queue. What are the advantages? Let me briefly describe about the headings. So first is decoupling. What do we call as decoupling? So message queues decouple producers and consumers, which allow them to operate independently. This enables more flexible and scalable architecture. The second is asynchronous processing. Asynchronous processing. Okay. So what is asynchronous processing? Suppose there is a producer which can send messages to the queue and move on to other tasks without waiting for consumer to process the message. This improves the overall system throughput. This is how asynchronous process works. The third is we have load balancing. So load balancing is one of the advantage of message queue. Let's see how it is a advantage. Multiple consumers can pull the message from the queue, like we have seen the broadcasting. So multiple consumers can easily pull the message from the queue, which allow work to be distributed and balanced across different consumers. This is how the load balance is enhanced. Okay. And the fourth is fault tolerance. How a message queue can be fault tolerant? So there is persistent message queue, which ensures that messages are not lost even if a consumer or producer fails. So as we have seen in the previous slide, even if the consumer is failing to get the message, we cannot say that we are completely failed. We still have a chance with the help of a dead letter queue to hold the message in the form of a queue, and when we are doing troubleshoot or any retry, we can easily get the message or we can try it again. Okay, so this is how it is fault tolerant. We are able to do the retries, and also we are able to do the error handling. Okay, this is how it is fault tolerant. The fifth is we are doing scalability. We are able to scale our architecture of system design. How? Like message queues can easily handle a large volume of messages by storing them in the form of first in first out queue. So it allows the systems to scale horizontally by adding more consumers. You can scale horizontally. We also call it as horizontal scaling. Horizontal scaling. Okay. The last one advantage is we are able to do the throttling. How we are able to achieve this? So message queue can help control the rate of message processing. We are able to control the rate of message processing because we are actually storing the messages before processing them. We are storing the messages in the form of message queue before actually giving it to the consumer. We are actually doing a rate limiting here. So it prevents the consumer from being overwhelmed. Now let's discuss when to use a message queue. This is very, very important. When do we actually use a message queue? So the first thing is we use in microservices architecture. Microservices architecture actually. Okay, here we have microservices architecture. What is the problem that occurs in microservices architecture that we actually solve? So the problem is microservices need to communicate with each other. Okay, they need to communicate with each other to share the progress of the process which they are working on. As you know that microservices are like small components which are distributed and they are actually working with each other with the help of intercommunication. So here we do not have a direct communication. Okay, direct communication can lead to tight coupling. Okay, and it also leads to the cascading failures. So this is the actual problem in microservices architecture. What is the solution that we have done with the help of message queues? So the solution is use message queues to enable asynchronous communication between the microservices, which allow each services to operate independently and resiliently. Okay, they operate independently. The second use case here is task scheduling and background processing. Task scheduling and background processing. What are the problems? So the problem is there are certain tasks such as you have image processing or you want to send an email. Okay, these are time consuming processes and should not block the main application flow. What is the solution? You are using message queue. Offload these tasks to the message queue and have background workers like consumers to process them asynchronously. That's the solution. The third advantage or third use case is event driven architecture. So we use an event driven architecture. What is the problem? There are certain events which need to be propagated to multiple services or components, but direct communication would be insufficient. Okay, and inefficient actually. And what is the solution here? We use a pub sub message queue to broadcast event to all the interested consumers, which ensure that all the parts of the system receive the necessary updates only. So we are actually providing them necessary update. It also able to, so we are also able to reach the targeted audience scenario here. Like as you have seen over YouTube, what kind of notifications you actually receive. For example, if you are a gamer or if you are interested in game, mostly you watch games over YouTube. So you receive notification regarding the game only. You are not actually receiving unnecessary notifications. So that is how it actually works. And it is also beneficial or used in load labeling. How it works in load labeling? So the problem is there are certain spikes in request that can overwhelm a system, which lead to degraded performance of the or we can say it leads to failures. Okay, what is the solution? So the solution is, you have a queue, you queue the incoming request in the message queue and process them at a steady rate. You have the ability to decide the rate. Okay, rate is steady here in the queue, and ensures that the system remains stable. Even if there is a load, the rate will be steady. Okay, so if we say we can have at a time, we can have 5 messages in the queue, and we can process them steady with a constant rate at a time. So this is known as load labeling. The fifth is, we have reliable communication. Reliable communication. How it actually says that we have reliable communication? So let's discuss about the problem. The problem is, like, you have communication between components which needs to be reliable even in the face of network or any service failure. It should be reliable, it should perform its working. Okay, so the solution is, we use here the persistent message queue to ensure that messages are not lost and can be retried even if the delivery fails. So let me go to the previous slide. So here we are using dead letter queue. Okay, it is actually giving us the persistence. Here we are able to persist our message, and we can say that we can easily retry with the help of troubleshooting or any kind of retry. Now let's discuss about the best practices that we should follow. So the first is idempotency. What is idempotency? So ensures that your consumer can handle the duplicate message gracefully, and as the message queue may deliver the same message more than once. Okay, so like we were performing delete operations previously, we were performing actually to have idempotency, to remove any kind of ambiguity and ambiguity regarding the duplication of the message. The second is, we have message durability. So choose in between whether you have persistent and transient message based on the criticality of the data. So persistent message ensures the reliability, but may come with performance trade-offs as well. Like you have storage cost as well, and performance in sense you are storing it, so you are also consuming the time. Hence you may increase the latency as well. So here the performance is degraded. The third is error handling. So what you should do is, you should always implement a robust error handling, and including retries. You should add troubleshooting and dead letter queues, as we have discussed already. You should have a alerting system to deal with the failed message processing. The fourth is, we have security. You should have secure your message queue. So you should implement an encryption technique, authentication and access control to protect the data which is in transit and is at rest. And the fifth best practice is, you should monitor and metric. Monitor and metric. What does it mean by monitor and metric? So you should set up a monitoring and metrics to track your performance. What is the health of your message queue, including the message throughput? What is the throughput of the message queue? What is the length of the message queue, means how many messages it can hold at a time. So you should be able to monitor on the dashboard, and you should be also able to check the consumer lag, where the consumer lag is. And the sixth or last is scalability. Scalability. So you should have a scalable message queue, which means plan for a scalability, like by choosing a message queue solution that can grow with your system, and whether by adding more consumer, whether you want to add more consumers, or partitioning the queue, or using a distributed message system. So these are the best practices you should perform while using message queue. The final topic is, what are the popular message queue system that we should use? So let me name them one by one. The first one is RabbitMQ. Okay, so we have RabbitMQ. It is a widely used open source message broker which support multiple messaging protocols, including AMQP. So it is known for its reliability and extensive features. So let me mention here, it is reliable and extensive. The second message queue provider is Apache Kafka. Okay, so Apache Kafka is a distributed streaming platform that excels at handling large volume of data. Apache Kafka is often used for real-time data processing. Okay, remember this. It is used for real-time data processing and also used for event streaming. Okay, the third message queue provider is Amazon SQS. We have Amazon SQS. So it is a fully managed message queue service provided by the Amazon Web Services. SQS is highly scalable and integrates well with other AWS services. So it is highly scalable. Okay, the fourth one is, we have Google Cloud PubSub. So we have Google Cloud PubSub. Okay, how it actually works? It is a fully managed message queue service offered by the Google Cloud. So it is designed for real-time analytics and event-driven applications. So we are able to do real-time analytics and monitoring. Okay, and like Google Cloud, Amazon, Apache Kafka, RabbitMQ, we also have Redis streams. We have Redis streams. It is a feature by Redis that provides a simple in-memory message queue with high performance and suitable for lightweight tasks especially. And the last one is, we have ActiveMQ. ActiveMQ is an open source message broker. It is a queue manager which supports various messaging protocols, and it is used in enterprise environments for reliable messaging. Thank you everyone for watching this video. I hope you guys are liking this system design playlist. And previously we have discussed about so many topics. There are around 32 very important fundamental topics we are actually covering right now. So do like, share and subscribe my YouTube channel. And do mention in the comment which part do you like the most, and whatever your questions are, do mention in the comment section as well. Thank you. Watch Code Money for more videos.